Question 19 is typical polynomial inequality. Okay, the solution of the polynomial inequality is only possible doing by using the method of the changing sign chart. So first of all, you must write the inequality. Try to get the right hand side must be 0. So right hand side must be 0. And try to manipulate factorization this part. The factorization, the GCF is obvious is x squared x minus 5 greater than or equal to 0. Okay? Now this is super important expression. Okay, now let's find the critical value. Critical value. For finding the critical value, we convert the inequality to equation and solve this equation. This is super elementary equation. The solution of this equation is 0 and 5. And this is our critical value. Okay, after that, we are doing one sketch in which you draw an all random line from positive infinity, negative infinity, and you put the critical value, okay, 0, and you split. This is the partition of the all random line, and 5, so I suppose is here. And you select arbitrary testing point before and after each critical value. So arbitrary, complete arbitrary, -1 for example, and between 0 and 5 maybe 1, maybe 2, doesn't matter, the answer doesn't change, and after 5 is 6. This is the testing point. Testing point. Okay, and when you have that, you are doing the famous chart. In the chart, we have a different testing point. Looking at what example is -1, +1, and +6. And the factor that we have in our problem is this factor is x squared x minus 5, and we include extra column que is the total sign. And we analyze just the sign. So inside here I only put plus or minus. I evaluate, for example, evaluate -1 inside. So I evaluate -1 inside this expression, this square. It's obvious it's +1, but I don't care the value, I care the sign. I put plus. Likewise, -1 here is -1 minus 5. It's obvious it's -6. It's negative. Positive, is this expression, times negative, is this expression. The answer is negative. Okay, 1 here. Well, this is always positive. Why? Because it's obvious. Okay, when this is square, always is positive. It doesn't matter if the testing points are positive or negative. The only change is this. The 1 here, 1 is 1 minus 5 -4, it's negative again. And 6 minus 5, 1 positive. Okay, so this is negative again, and this is positive. Okay, so what is the true part? What is the part that is valid, this inequality? The part that is valid in this inequality is only here. Why? True. Because our inequality is greater than or equal to 0, that means it's positive. When this negative, no, it's completely false. This is false, and this is false. And the true part of this and this interval corresponding with the solution, the interval corresponding with the solution is when we have testing point 6, que es this part. Entonces is I shade or highlight this part. I don't know. Remember, our original problem is not a strict inequality. Now it's a combination, a strict inequality or equation, because this sign is greater than or equal, and the solution for this part is this interval I put in blue, and the solution for this equation is 0 and 5, que is exactly the same, the critical value. Now that means that the solution includes 5 bracket here and include one extra point 0 here. Now the solution set of the our inequality, or the solution set, is bracket 5 comma infinity union 0, que is one point isolated, que corresponde with the option B.